This lesson is on simplifying nth roots. So we just did a little bit of this on our last lesson, but now we're going to take it a little bit further and we're going to include some variables as well. So I touched on this a little bit on the last video, but if you have something that is written to a power, then we're just going to worry about reducing that index. So 4 divided by 4 gives me x to the first. 20 divided by 4 gives me y to the fifth. Now, this part is pretty important, however, the whole whether or not you need absolute value. Now, I know that if I take the fourth root of something, I know that that had to have been positive in order for me to take the fourth root. So that is why if we have an even index and an even root, we need to make sure that's in those absolute value signs, because if it's not, then there's no way for me to know that if it was a negative that it wouldn't have worked. So make sure that you're taking the absolute value if it's an even index. Negative 27a to the sixth, again this is an odd root, so that's good. The 27 we could break down as we did before, 3 times 9, which is 3 times 3, and so that negative, because it was negative 27, would bring the negative 3 out, and then 6 divided by 3 is 2, so negative 3a squared. So let's simplify these nth roots together. Again, whenever we have an even index, you have to be very careful. So this index is 2, so we're going to have to be careful on this one. This index is 4, so we're going to have to be careful on this one. So t to the sixth, when it's already written as a power, it's very easy. 6 divided by 2 is 3, so this is t to the third. However, this was an even index, so I need to make sure that that is the absolute value. For my next, I have 27a to the third. 27, we already know the cubed root is 3. 3 divided by 3 is 1, so that's just 3a. I don't need to do an absolute value here because it's an odd index. And last one, 81. 81 is 9 times 9, which is a lot of 3s, basically 4 3s. So that brings the 3 out front. 4 divided by 4 is x to the first. 8 divided by 4 is y squared. And then 16, the cubed root, or the fourth root of that is 2. And then, of course, I've got the negative on the outside, but all of this needs to be in the absolute value. Try these 3 on your own, then press play to see how you did. For the first, I have 64. So 64 is 8 times 8. And 8 times 8 is 4 times 2, which is 2 times 2. 4 times 2, which is 2 times 2, and so I end up with 1, 2, 3, 4, 5, 6, and if I divide that by 3, so essentially I'm taking the cubed root of 2 to the 6th, y to the 12th. If I divide, that gives me 2 squared y to the 4th, and of course I wouldn't leave it as 2 squared, I would write 4y to the 4th. Because it's an odd root, I don't have to do anything with an absolute value. My second example, I have the fourth root of x to the 4th. 4 divided by 4 is 1, so that's just x. The fourth root of y to the 4th, 4 divided by 4 is 1. It is an even root, and so I'm going to put that in the absolute value brackets. And last, 32. The fifth root of 32 is 2. 5 divided by 5 is 1. 10 divided by 5 is 2. And I'll have the negative on the outside, and I don't have to worry about absolute value.